Right, now we will see the properties of RC driving point emittance. So as I already told, emittance is a term used to convey both impedance as well as admittance. So emittance function is can be either impedance function or admittance function. So here we have already seen the properties of LC function. Now we will be seeing the properties of RC function along with an example. Okay, so there are 7 properties. The first one is saying that the poles and zeros are simple and are located on the negative real axis of the S-plane. So if you can compare this with LC function, there for the LC function we are having poles as well as zeros only on the j omega axis, no poles and zeros on the left or right half of the S-plane. But here the poles and zeros are simple and are located on the negative real axis of the S-plane. Fine. Right, the second one is that the poles and zeros are interlaced. So even though they are lying on the real axis, they should be interlaced, which is same as that of LC function. So at every point you get a comparison with LC function or maybe with RL function. Right, okay, now the third one is saying that the lowest critical frequency nearest to the origin is a pole. So critical frequency is nothing but the location of the pole or the S value. Fine. And the lowest critical frequency nearest to the origin should be a pole. Similarly, the highest critical frequency farthest to the origin must be a zero. Right, that means which is far from the origin must be a zero, which is close to the origin must be a pole. So with the example you will get a very clear idea. Right, next the fifth one is saying that the residues evaluated at the poles of RC function must be real and positive. Okay, and the slope d by d sigma ZRC is negative. So this is a bit tricky here. So let me clearly write this. How to determine this d by d sigma ZRC? So this is nothing but d by d S of ZRC of S at S is equal to sigma. Fine, this is how you are going to determine d by d sigma of ZRC. Fine, don't confuse, it is the differentiation with respect to S, and then you need to substitute sigma in place of S. Then that value should be negative. If it is negative, then only it becomes RC function. That is the meaning of the sixth property. And there is last one, which is saying that the ZRC at infinity must be less than ZRC at 0. Right, all these things you can observe for a given RC function. Okay, now we will see an example. Fine, let us see these two examples and we will check whether these functions are RC functions or not. So part A is impedance function and even part B is also impedance, even though it is not mentioned in the solution. You can see whatever it is, and from the given function, whenever you are asked to determine or check whether the function is RC, RL or LC, first step is to draw pole zero plot. Fine, from the pole zero plot you can identify the particular function which is of which type. Okay, so when you plot pole zero diagram here, we have poles at -3 and we have zeros at -2 and -4. So they are interlacing because first we have 0, then pole, then again 0. Right, but oh sorry, we have one pole at origin also, right? Okay, that means near to the origin we have pole, that means which is origin itself. right? That property is also satisfied here. Also for RC function, the highest critical frequency which is far from the origin must be a 0, and that is also satisfied here. So the close to the origin one is pole and the far to the origin is 0. That means even if you check all other properties, they will be satisfied, and you can directly write down that this given function is a RC function. Fine. Right. Now we will see the second part of the problem, the other function. For this function, as per the requirement, all poles and zeros are on the real axis. That is fine, but and they are also interlaced, because first we have 0, then pole, then 0, again pole. But there is one property which is not satisfying here, because we need to have near to the origin pole for an RC function, but here we have a 0, so which is violating the property, right? With this we can directly say that this part B question is not an RC function, right? That's it. This is how we need to check about the RC functions or not, right? That's it. Thank you.